Greetings, fellow nerds. This is your host, the Mediocre Engineer. Welcome to the first in our series of software engineering war stories, tales of the code that will chill your spine and hopefully teach you something along the way by looking at real-world programming problems. Today, we're featuring a story from my own past. Don't worry, the names have been changed to protect the innocent and the guilty. So without much further ado, we begin the case of too many emails. The year is sometime around 2015, and I, the mediocre engineer, have just been hired to a prominent financial technology company here in the San Francisco Bay Area. The team I'm drafted into is in charge of replacing an existing internal email marketing system. Now, the existing system had served well enough for a few years, but it was fast approaching its limit. As a daily process, it needs to finish inside of 24 hours, and as of my onboarding, it had just started eclipsing that mark for the first time. The load of the current system is causing major stress breakage all throughout production, generating tons of on-call errors and just tons of problems. Then to add insult to injury, every time this process doesn't finish, we as a company are leaving money on the floor. All this marketing that we put together to send out isn't going anywhere. The writing's on the wall. We need to get ahead of this problem, like yesterday. First, let's talk about why the existing system had such a dramatic impact on production. In this company setup, they were using a LAMP monolith that had been around since the beginning of the company, and at some point it had a background job system bolted onto it and extended. Which, again, worked well enough for a while, but here's the problem. The way that this system worked is that the background jobs ran on the same servers as the website. So as either side needed resources, the other would suffer. If there were too many emails to send, production web traffic would slow down. Or if we had too many people going to the website, we wouldn't be able to send enough emails. Now, initially though, this seems like it shouldn't be as much of an issue as it turned out to be. Why would sending even 10 million emails take this many resources? Well, let's take a look. The existing process would start via a master job, which would kick off nightly, as soon as the daily maintenance window had closed. So for us, this was around 12:30 a.m. The master job would begin by first gathering up all the active marketing campaigns. Then, and anyone who's done some basic leak code lately is going to see the problem here, it would run an inner loop going from user ID 1 to the most recent user ID and spawn a child job that would do some further work. Now, to note, when I joined the company, the highest, user ID was around 155 million, and they had around 300 campaigns running. That's about 46 billion operations every day, or 500,000 every second. So 46 billion times, we'd get the data for a single user, evaluate them against some rules that were baked into the campaign. These were pieces of code that would say, hey, can I do this? Have you been contacted in the most, X amount of days? Things like that. Most often, we would find that the answer was no, we cannot send this person any email. But on the relatively rare occasion that it passed all of the checks, the monolith would then render a template and send the email by delivering it to a third-party email vendor. Now, most engineers are probably pulling their hair out at how self-inflicted this problem is, but so it was. So now that we understand the problem being that we have a nested loop and O of n squared runtime, let's take a look at how we can get to a better solution. Now, I cannot take credit for this solution. It was designed by a staff engineer at the company who was part of our team for a short time. He is one of the best engineers I've had the pleasure of working with, so let's dig into how he flipped this problem on its head. To set some important context before we dig into the solution further, I just want to note that the company at this time was in process of embracing the cloud for the very first time via an exclusive contract with the Google Cloud Platform. And much to our delight, one of our data engineering teams had already set up a prod-like instance in BigQuery where we could get most of our data. So let's take a look at what it looks like. To cross the cloud barrier, as Google Cloud couldn't call into our production VPC, we ended up going with a producer and consumer setup. So first things first, how are we going to produce what emails need to get sent? First, we plan to make use of Airflow to schedule a Google Dataflow pipeline to run daily. We chose Dataflow as this is an auto-scaling pipeline task runner that could easily use BigQuery as a source and PubSub as a sink. The pipeline would start the same way, fetching all of the active campaigns. Then it would perform the key difference. It would run a targeting query. This flips the problem of combing through every user and asking, hey, can I send it to you? Hey, can I send this to you? Hey, can I send this to you? It uses the SQL engine to say, give me all the people who I can send to. The analogy that the designer of this solution liked to use was, instead of looking for needles in a haystack, just say, hey, give me all the needles. This would require rewriting the code-based eligibility rules into SQL queries, but really that wasn't that bad. Finally, we would run a second query to gather up what data needed to be there for the template to get sent, and then publish it onto a queue. On the consumer side of the equation, inside of our production VPC, we would start by polling the queue. We plan to bake this into the general notification sending service. First, the service would get the campaigns from a campaign manager microservice. Using information contained within the campaign, the service would then fetch the associated template from a template manager microservice. Once the template was acquired, it would render the template with the provided data and then pass it to the touchpoint gate. Here near the end of the stream, we had a touchpoint gate feature that acted as a goalie. It would only allow marketing emails to the same email address to go out once every 24 hours. This is what allowed us not to have to worry about the same day overlap between the marketing campaigns and later separate systems. Finally, we would send to the third-party vendor who added tracking and other things, and then record success and failure. Once recorded, we'd have an ETL process that would ship the outcome back up to BigQuery. So that's it. That's the plan for what we had to build. A producer that auto-scales, does all the work as quickly as we want to pay for, and then a trio of microservices that actually do the sending. Now that we had a plan in place, let's talk about how the build went. When migrating from one system to another, there's always a period of split brain where decisions about the same process are being made by two separate systems. Depending on the problem, you can dual write or bring traffic over gradually. But given the unique interactions between our campaigns, this is how we plan to get from point A to point B. In the monolith, the first change we planned to make was to have it called a notification service. This would provide the benefit of that goalie that I referenced earlier, which would be the key in the two systems not stepping on each other. So instead of the monolith reaching directly out to a third-party API, we would instead pass a request along to the notification sending service. Inside of the notification sending service, we needed a way to ship the recording of someone being sent an email to be available somewhere that the monolith could see and use it. So what we ended up doing was adding an ETL job to load that information back into the monolith database. And with those two changes, we were ready to start building the main data flow pipeline. As the old saying goes, what can go wrong will go wrong. And we absolutely experienced that during the run of this project. Both in keeping the lights on of the old system and during the build of the new system, both provided some interesting wrinkles. The thing that probably blindsided us the most during this project was the expense of keeping the lights on for the old system. As I had mentioned earlier, when I joined this team, we were already hitting runtimes of over 24 hours, and during my tour of duty, marketing continued to add new campaigns as more people signed up for the platform. We had about 170 million users within 6 months of me starting, and another 100 campaigns. This was the proverbial poo hitting the fan moment, as the system just buckled under the weight of what we were asking it to do. With the added load, the legacy system easily ran over the allotted 24 hours every night, losing revenue in the process. This led to the worst on-call experience of my entire career. Upwards of 80% of the time there was an incident. This meant that if you were on call 5 or more nights a week, you would be woken up during the night for a high-stress, hours-long bug fix. This would last 7 days a week for 2 weeks, followed by being secondary for 2 more weeks. Now, at this particular company, you were also expected to work a regular workload on top of it. Management had said that this wouldn't be the case, but that's not really how it worked out. But as you may expect, this high-stress environment had the effect of burning people out and making them quit. Out of a 12-person team, we had 10 people come and go or get reallocated by team reorganizations. That's close to a 100% turnover rate, which is insanely high. With each person that left, the team would be set back just a little more. Now, while the keeping the lights on work was bad enough, we also ran into some trouble building the new system. As we moved campaigns over, we found that they were taking a very long time to run, like 12 hours. Digging in, we discovered that Dataflow was not actually doing any auto-scaling, and after a lot of configuration tweaks and back and forth with Google support, it turned out that our workload, being mostly I/O bound, wasn't using enough CPU to cause auto-scaling. It wasn't like AWS where you could set a custom CloudWatch alarm or something along those lines to cause scaling events. The system itself had full control. Additionally, the campaigns we did move over suddenly had wildly different metrics than they did in the old system. This put our progress on the project to a full stop while we investigated it. The investigation dragged on and on for months and never fully yielded good answers, mostly because, one, you can't compare month to month, as you're targeting different people in different situations each month. Two, we never identified the veracity of the old system. Just because it was reporting numbers doesn't mean they're right. And three, we didn't decide which metrics were important in the beginning. Really, all that mattered at the end of the day was revenue. Additionally, we ended up having to work with our email API vendor, as we turned out to kind of DDoS their endpoint. Going from doing 15 million transactions or so over the course of a day versus as quickly as we could do them was a pretty big increase. Another gotcha for us was that the team hadn't built their template and campaign managers in such a way to stay in lockstep with the existing changes. So, while the new system was being built, dozens of marketers continued to work and make changes. So all the templates and campaigns in the new system were way out of date. As a way to make up the difference, we ended up drafting 6 other engineering teams and basically getting a week's worth of effort from each to help us port over the campaigns and all the templates. After almost a year worth of effort, with all the many problems we've talked about behind us, how did the system end up looking in the end? Well, for starters, Airflow was unfortunately kiboshed by our security team. To this day, I'm unclear as to what Airflow did or didn't do that led to its rejection, but as a non-starter, we ended up using a Google Cloud function to invoke the pipeline instead, running on a cron schedule. Now, for what was one of the bigger kicks in the pants, as I mentioned earlier, Dataflow would not scale to our workload. So the solution that Google support recommended to us was to scale vertically and use standard Java multi-threading, and that's where we ended up. Perhaps not the best solution, but it got us where we needed to be well enough. The rest of the system was built pretty much as expected. We ended up doing some batching for the gathering of user data that got us a 26x speed increase, but everything else was straightforward. Now for the real question. This project in total took about 18 months, give or take a quarter. It had 1 eng manager, 1 staff engineer, 3 senior engineers, and 6 other engineers between levels 1 and 4, and a TPM. 10 staff were lost to attrition and replaced. 40 staff were used for 1 week to port templates. There were around 18 days where emails were severely impacted or not sent. The total cost of this project was probably around $15 million, all said and done. Our big wins are mostly due to the reduction in load on production. The old system dying took many thousands of lines of code out of the code base. It dropped the load on our PHP servers by about half. On-call incidents around the email system dropped from multiple every day to 2 to 3 a week, usually handleable during business hours. And we unlocked the marketing team. They can now easily add 10 times the number of campaigns they were running with no adverse effects. Now let's talk about our losses. As already mentioned, there was lots of team churn. In addition to that, the cost in health. Most every engineer had to spend weeks out sick. Loss of confidence in Google Cloud. And, unfortunately, we ended up with somewhat of a late delivery due to our investigation into why there was a drift between metrics in one system and metric in the other. Late delivery is bad for everyone. Now I have to ask ourselves, what can we learn from this project? As a manager and lead, the first thing to understand is the limits of your team. If we had divided the team into a couple of third shift people, for even a short while, I think we would have been able to keep up with the stresses of the production system and maintain a better overall velocity. When adopting a new technology, take the time to become fully educated on it. If someone on the team had studied Google Cloud to the equivalency level of an AWS associate, it would have been totally valuable for us to know. When designing batch systems, be aware of how they will grow over time. If at all possible, avoid time-based batch processes. If you're ever doing a nested for loop, stop and ask yourself if there's a better way. Get to know your customers. get to know what they consider success and failure. In this case, none of the engineers had ever done marketing, and I think knowing how often the data changed would have been beneficial to get ahead on some of our issues. Lastly, when problems do come up, as they always do, making sure that everyone agrees on the key metrics for success are what's really important. Thanks for listening to the case of too many emails. Remember, batch processes can come back to bite you, and always know your algorithmic complexity. Until next time, I'm the Mediocre Engineer, and this has been In the Trenches, Software War Stories. Do you have a software war story of your own? We'd love to interview you. Get in touch with us via email at eng@mediocreengineer.com, Reddit at r/mediocre_engineer, or here on YouTube at The Mediocre Engineer. Thanks for watching us, and remember, even if you start mediocre, you can end up great.